All right, page 2. What are the transformations of the functions? When I look at this, I see my reflection. When I look at here, I see a stretch of 2. When I look here, remember it's opposite of sign, it's going to go left 2. And when I look at this value here, I realize it's moving down 3. All right, what is the vertex of the function? We'll go ahead and calculate negative b over 2a is equal to the x coordinate. Here's a, here's b. So I have negative 8 over 2 times 2 is equal to my x. Negative 8 divided by 4 is negative 2 is equal to your x. When I know the vertex, I know that that's the x coordinate is negative 2. My job is now to find the y coordinate. So I can put y is equal to 2 times negative 2 squared plus 8 times negative 2 minus 5. If you don't trust your calculating skills, you can always type the equation in, 2x squared plus 8x minus 5. You can always graph it. Go to the table of values. Go to negative 2 and see that negative 13 is your output. You can also enter this equation in, 2 times negative 2 squared. If you don't use parentheses, the calculator will not follow the order of operations that you want it to, and you'll end up with a wrong answer. So make sure you use these parentheses. Negative 13. Okay. Number 6, what are the zeros of the functions? This negative doesn't matter. All I care about are the x-intercepts. So x is going to be equal to negative 6 and positive 1. Domain and range. Your domain is going to be all real numbers from negative infinity to positive infinity. And your range is going to be equal to, if I look at a sketch of this graph, plus 4, and it's the parent function gone down. So my range is going to be all the values from negative infinity up to and including 4. All right, on to the charts. These puzzle pieces are fun to fill in. So when I look here, the quadratic equation, I'm going to see if I can factor it. When I factor it, x times x is x squared. Two numbers that multiply together to give me negative 6 and add together to give me negative 1. I know one's positive. I know one's negative because this sign is negative. My greater value is negative because it carries the sign. So plus 2 minus 3. So my factors, x plus 2 and x minus 3, are going to give me the zeros or the roots of negative 2, positive 3. And when I sketch the graph identifying the x-intercepts, negative 2, 1, 2, positive 3, it's a positive graph. So we'll go ahead and just sketch the graph. If we see the word sketch, we can just draw a generic picture. Okay, from these factors come these roots. And when I want to write the equation, I recognize that these two factors could represent my equation in intercept form. If I wanted to multiply x squared minus 3x plus x minus 3, standard form then would be x squared minus 2x minus 3 is equal to y. And here's my graph. Alright, when I look at this graph, I see a 0 at -6 and a 0 at +3. So my x is equal to 0 at -6, 0 at +3. My x is equal to -6 and 3, which means my factors were x plus 6, x minus 3. I get these factors because if you think x is equal to -6, when I add 6 to each side, I get x plus 6 is equal to 0. That's how I grab my factor. X was equal to 3. If I subtract 3 from each side, x minus 3 is my factor. When I write my quadratic equation in intercept form, x plus 6, x minus 3. When I put it in standard form, x squared plus 6x minus 3x is equal to y. X squared plus 3x is equal, oh, I forgot my constant. X squared plus 6x minus 3x, minus 18. X squared plus 3x minus 18, that's better, is equal to y. Alright, page 2 done.